Hey, so now we will learn about the stack and how these stacks works and what is the stack first of all, then what are the properties of it, and then some problems based on the stack we will solve here. And let's start with the writing or understanding the stack, what it is. So stack is a linear data type, in which we store the data. So arrays we all know, right? Arrays we all know already. Okay, there was something, so I just fixed it now. So arrays we all know, as we know, right? So these are the array in which these are the linear data structure which are numerically indexed. So we know data structure. So now think about the stack. What is the stack? If you think the word stack itself, then you will say there is a pile of books or a stack of books. You might think of that. So, so, so that is the data structure. So what rule stack follows is the rule it follows is LIFO, last in first out. What it means is, suppose there is a black box in which you are pushing you are giving the numbers to it. Suppose I'm saying ki have the first I send a charger to it, second I send a mouse to it, third I send a book to it. And now if I ask, give my product one by one, then it will give first book, then second mouse. So whatever the last inserted in this black box, this black box is stack. Last inserted in it, and that will that we can get first. So that's why it is follows LIFO, last in first out. Okay. And now we will look into some of the properties of it. Okay, let's see. So here if you see, so there was a black box. We are inserting some product or objects to it. So to insert objects into the stack, we use push. To extract or remove objects from the stack, we use pop. These are the method name. And to check what is the last inserted object, we use pick. And if there is any object or not, we use empty, right? And now let's see, for each of these each of these operations, there is only big of one time complexity. Use case of stacks, it is used in browser history function. There's a lot of things it is used. Okay, let's go and start seeing the problems those we can solve based on it. So we have this first problem which is says, okay, given a string as containing these characters, determine if the given strings of parentheses is balanced or not. We just need to check is this string is balanced or not. Okay, cool. So if I come here and then see, so if you see this is completely balanced, right? We can say clearly. So this closed this closed this. And if I just rearrange it, by the way, this closed this, but it is not balanced. Okay, okay, cool. And there is another condition. This not balanced because none of them is closing. Now the thing is how we will going to solve it. And if you take big problem as a question statement, you can take this. Sorry. This is also balanced. If you want to see that is it balanced or not, we can confirm here though. So this one, I'm just writing exactly what I wrote there. And let's see, is it balanced or not? Run. Okay, output is okay, expected is true, so it is balanced, right? So now we know what are the balanced and not balanced strings. Now we need to check how can we confirm these are balanced or not. So there is one more. We can see this thing also. So this is a balanced. No, how can we check it? So I have solution for it. We will going to use a stack. Okay. If what I'll do, I'll traverse from start to end and then see what happens. Okay, traverse I so if while नहीं for loop I 0 to n तक सारे के सारे को चेक करते हैं. इफ एस आई बराबर बराबर ये है और ये है. If it is belongs to these three, then I'll push them directly without thinking anything. So first this thing I pushed it, and if si if si belongs to this or this, then I'll check. Then I'll check. I'll pop one item from the stack and then see if it is this one. If opposite matching opposite matching, then we don't do anything. If opposite not matching, to return false. That means it is not same. In this case, so if you take this one, so first I inserted a square bracket opening, then I inserted curly bracket opening, then I see this one. So, but I pop this one. These are not opposite to each other. That means it is not following the rule. So we return the false. And that's it. This will solve the issue. So if you want to check is it work or not, we can try to run the first problem. So first of all, we inserted this and then if this come up, we can say these are opposite, then we pop this one, then inserted this. The next one is opposite of this, then it will popped. Then next one is this, and then this is opposite popped. Then next one is closing curly braces, then this is popped, right? And then again curly braces, then again opposite curly braces to popped, then opposite popped. So now last में at the outside of this, if stack is empty, that means true, else false. So let's write it down. So here is the solution. We created this opposite map here, and then here we created a array stack, and if it is belongs to these, then we are pushing it, and if it belongs to these, then we are checking is opposite is equals to si or not, or the current present index or not. If not, then we are returning false. Else we are checking stack length is 0, then it is true, else it is false. So here is this solution and this is done. Okay, let's move to the next one. So in this question, given a string, write a function that uses stack to reverse the string. The function should return the reversed string. So okay, So here is this word, hello world, and for this string, what it is doing? It is just doing this. Okay, let's see how can we solve it by using this stack. So it's pretty simple if you see that. So here is this A, B, sorry, here is hello. Okay, so I put one by one, start from the one H E L L O, and then pop pop, then pop L, then pop E, then pop H, and then it will become the reversed string, right? So yeah, let's implement it. So here is the solution. So we have created a stack. Here we are pushing every word, every letter into the stack. Then we initiate this as an empty string. Then we are adding by popping from the stack. Okay, cool. So this is working, and let's move to the. So here we can see, given a positive integer n, write a function that returns its binary equivalent at a string as a string. The function should not use any built-in binary conversion function. Okay, so we have 2, the 2 will look like this. We have 7, then 7 look like this. Then we have 18, then 18 looks like this. Okay, so how are we going to solve it? That's the question we need to tackle. Okay, cool. So here suppose we have 18. How we normally evaluate the binary numbers, or convert it to the binary? What I remember is we start by dividing 2, divided by 2, and then check. Okay, is okay, 18 modulo 2 is 0, and 18 divided by 2 will become temp. Okay, temporary, that is no. So we'll store this 0 somewhere, like 0, then again 9 by 2, sorry, 9 divided by modulo by 2, 9 modulo 2 equals to 1, so we'll say 1. Then 9 divided by 2 equals to 4, 4 modulo 2 equals to 0, 0, and 4 divided by 2 equals to 2, 2 modulo 2 बराबर 0, 0, and 2 divided by 2 बराबर 1, 1 modulo 2 बराबर 1, and 1 divided by 2 बराबर 0, right? Mhm. So 1 0, so here will come 1. So this is the solution for 18. So 0 plus 2 plus 4 plus 8 plus 16, so it will become 18. So this is the answer. Okay, now how we can, why we need to use the stack in it, I don't know, but yeah, maybe to save these values inside the stack. So first comes 0, 1 0 0 1, and then we'll say 1 0 0 1 0. Maybe this for this one. Yeah, okay, it's okay. Let's implement it. So here is the solution. So what I'm doing is, here is this number, and I'm pushing the modulus by 2 into the stack, and then finding the result by dividing by 2, and then reversing the stack, and then joining by the empty string. That will become the binary equivalent of it. So yeah, this is how we solve it. Let's see how they solved it. So stack, and then num is greater than 0. Modulo math floor, I don't need it because I used stack reverse join. Perfectly fine. We also did the same way. Let's move. So the next question is about, given an array, print the next greater element for every element. The next greater element for an element x is the first greater element on the right side of x in the array elements for which no greater element exists. Consider the next element as negative one. Okay, so next greater element. So 2 का next greater element is 25. 25 के आगे nothing, so that's why minus 1. Then 5 का next greater, because 5 से छोटा है, that's why we use 25. Okay. Okay, go. 2, 3, 4, 5. Okay, let's pick this example and add 13 in the start and then see how can you solve it. Okay, go. So the example is 13, 1, 2, 3, 4, 5, and this one. So here, mm, one more thing I can do here is 4, 3, 5. Yeah, this is what I can do. I can remove this also. Add 2 here, remove this. Okay. This is my ideal scenario. अगर I start from the back, 5 से आगे any greatest, there is no greatest at all. So minus 1. And then 3 के आगे any greatest, no greatest at all. There is a, so minus 1, so no greatest, but this is the, so if there is no greatest, then we'll add 5 into the stack, right? And then we'll come here and then check. इसके आगे कोई greatest है? I will check. Okay, 5 is the one that is greater than this. That is greater than this. So I will say 5 comes here and 3 goes into it, right? Or maybe इसके आगे 2 या something else. And then I'll come at the fourth. Then check. It is greater. No, I'll remove it. Then I'll check. Okay, the 5 is greater than. Then the fourth next greatest is 5. Then I come to 2 and then insert the 4 inside it. Next greatest, it is saying 4, and then I'll check for 2. Next greatest is 4, so I will say 4 and then insert 2. 13. I will check. Okay, 2 is not a next greatest, 3 is not a next greatest, it's empty, so then minus 1. So this is the solution for it. Okay, so we apply a for loop. Start from n to 0 के लिए, and if 0 के लिए, if ai, first thing, if stack empty है, so we don't do anything. Stack empty है, तो I will say new, it will be next greatest बराबर an empty array with null, right? So next greatest I will become minus 1 if it is empty. if if else अगर ये empty नहीं है, stack is not empty, in that case we will apply a while loop and remove all of the element which are smaller than this, while ai is greater than ai is greater than peak of the stack, then pop कर देंगे हम, ठीक है, and well, I just popped it. Now I know certainly. Okay, maybe instead of doing this, what can I do is, and you get it. You get the solution. How we're going to do? I'll just implement it and then tell you how we're going to do it in the code base. Okay, cool. See. So here is the solution for that. So this is what created a response or result. So it is already filled by -1, and this is the stack. And we are removing from the stack until or unless the peak is greater than the array I. And then if the stack length is still exist, then we'll set the peak value to the res result key index, and else we will just or and we will just push the current index array, right? This is the solution, pretty much straightforward. Okay, cool. So let's move to the next question now. Okay, so the next question is sorting a stack. Given a stack sorted using only stack operation, you can use an additional temporary stack, but you may not copy the elements into any other data structure such as an array. The value in the stack are to be sorted in descending order with the largest elements on top. Okay, with the largest element on the top. So this is how we need to sort them by using an extra temporary sort. How can we solve it? Let's see. Okay. So suppose we have one stack, this one, which have three, four, five, sorry, three, one, 5, 1, 3, and you have one another stack that is this. Let's start sorting them. Okay. What can I look for is, mm, I can just push 5 here, and then if if and only if 1 is less than 5, then put it there. 3 is not less than 5, right? So what I'll do is, we'll again pop them 1, and this is not less than, right? Okay, let's think about this way. We have only two stacks. What we can do is we solve the smallest problem first. Smallest problem is if there is only one element. If there is only one element in this scenario, what will happen is that it is already sorted. So if length बराबर बराबर 1, then return it. No issues. Let's, if there are two elements, 2. Okay, so what I'll do is I'll check, move this 2 there. Cool. If if this is the O, this is the second, this is the first stack, this is the second, or the another way, this is the stack, this is the temporary stack. Okay, so stack peak is less than the temporary peak. What I'll do, I'll just push it inside this. So I push it there. Okay, so now this is empty, so these are already sorted. So 2, sorry, 2 and 1, these are sorted already. But suppose they are not already sorted, what will happen? So instead of 2 1, if they are 1 2, these are not sorted already, but these are two elements, what will happen? I will push it here and then check. Okay, this is the 2. If it is not, this is not following this, then I'll extract it as a as a as a sorting element. Sorting element, it become 2. So this is not, nothing is there. Now I will just again pour them back. It will come here and then put the 2 at the top of it, and you will see. Okay, now it is solved. Right, now it is sorted. If there are 3 elements, how we will going to do them? And 3 2 1, not 3 2 1, 1 2 3, these are not sorted at all. So first of all we sort them, then we sort, because this is already sorted, then we'll sort this one, and this is what we can do, right? Okay. Hmm. Okay, cool. So for today, I will be doing this much of the questions. Okay, so because टाइम की कमी की वजह से अपने को यहीं पे रोकना पड़ेगा. Okay, see you soon. Bye bye. See you.